Hello everyone, welcome to my channel Learning Math with Shelly. In this video, I'm gonna cover exercise 2B, not all the questions, but a few questions, let's say 2 to 3 questions, along with the concept of velocity time graphs. So first topic here is velocity time graph. Velocity time graph is basically a graph between the two quantities as mentioned. One is time and the second one is velocity. And the most important thing that we need to remember is that velocity will always be represented along the y-axis, which is our vertical axis here. And the another one is the time, that is the x-axis. And when we represent the time here, we need to mention here if it is measured in seconds and the velocity if it is measured in the meter per seconds. So always remember velocity time graph is a graph between the two quantities velocity and time. Velocity will always be represented along the y-axis and time with the x-axis, and make sure you mention the units as well. Now we have different categories of velocity time graph. So the first part is here, this is a velocity time graph, and we see that this is a straight line given which is a horizontal line. Now, what is the meaning of this horizontal line? If you see at different timings, even initial time and time t is 0, and if it keeps increasing this time, you will see the velocity is not changing. Velocity is same everywhere. This height is same. Let's say it is a meter per second or any value. For example, I'm taking a numerical value here. Let's say this value is 10 meter per second. So when time t is equal to 1 second, then it is 10 meter per second. When time is t equal to 2 seconds, then also it is 10 meter per second. So that means velocity is not zero, but velocity is not changing as well. So we will say that velocity is unchanging and the object is moving with a constant velocity. There is no change in the velocity. And when we say there is no change in the velocity, that means there is a new term acceleration that will be zero. Why? Because acceleration is the change in velocity with respect to time. But here time is changing, but velocity is not changing. So acceleration is given like this. Acceleration is change in the velocity over change in time. This delta, this triangle sign is showing the change. So here time is getting changed, but there is no change in the velocity. It is zero. So acceleration will come out as zero. Then we have a second case. Here, the object is shown on, across this blue line, and we see that the velocity is zero because this is on the x-axis itself. So as the time is increasing, there is no change in the velocity. Initially, the object is at rest and it keeps on resting as long as the time is changing. So that means velocity is zero and object is stationary. So in sometimes what will happen, in the questions it will be written the object is stationary. So when it is written object is stationary, you need to understand by yourself that object stationary means its velocity will be zero. So this is a different way to say the same thing. Next we have a case where the velocity is changing over the time. If we say, let's say this is t equal to 1 second, so here the velocity is having this value. Then if it is t is equal to 2 seconds, then velocity is changing and it is occupying this value. So we see that as the time is increasing, here velocity is changing and basically velocity is increasing here. Okay, velocity can increase over a period of time. It can remain constant, it can be zero, it can decrease also. So here what is happening, velocity is increasing with change in time or increase in time. That means there is an acceleration because velocity is changing. Now because this graph is a straight line, and the graph here, for example, if I find out this one, here the time is 1 second and here the time is 2 second, and let's say the velocity here is v1 and here the velocity is v2. So we know that acceleration is equal to the change in velocity over the change in time. So here what is happening? This V2 minus V1 over T2 minus T1, this is basically like the gradient of this line which is shown here, and gradient of a straight line is always constant. So here it is a straight line, its gradient will be always same. So we will say there is a constant change in the velocity, and that change in the velocity is constant. Means if you move from t equal to 1 to 2 second, it is same the change in velocity from 2 to 3 seconds and so on. Okay, so we need to remember one thing very important here, that object is moving with the constant acceleration. Why? Because we are finding the gradient. When we say acceleration is v2 minus v1 over t2 minus t1, this is similar to rise over run, and we know that for a line the rise over run is always a constant value. So that means here the change in velocity with time, it will be constant. So there is a constant acceleration. All right. Now we go to the next point, that what is the meaning of acceleration? We already have discussed acceleration is the rate of change of velocity. See, either you say change in velocity with change in time, change in velocity with change in time. Either you can say like this, that this is the velocity, this is acceleration, or the time rate of change of velocity or rate of change, they have the same meaning. So now we have here, in velocity time graph, the gradient represents the acceleration. This is very important point. Sometimes it will not be given directly in the question, we need to understand it by ourselves. And then the second point is, if the velocity time graph is a straight line, acceleration is a constant. So every case, if it is a straight line like diagonal line, then acceleration will be constant, 2 meters per second square, 3 meter per second square, and so on. But if it is a straight line velocity time graph, but it is something like this, a horizontal line, then in this case acceleration is 0. Clear? Now we have unit of acceleration is either meter per second square or kilometers per hour, like that, hour square, like this way. Now we are prepared for the questions. With just one point more I have to discuss here, and that point is here. This is a velocity time graph is given, and here the velocity is constant, and we are saying that this area is basically representing, if we find out this area, so this is the area of a rectangle which is having time as one side and velocity is the another. So if I times these two values for this area of rectangle, this will give me what? Displacement. This is a very important point, that if you have a velocity time graph, this is very important for us to understand, that we are talking about the velocity time graph. So whenever you have to identify, like, okay, is it a displacement or is it an acceleration or whatever? So if it is a velocity time graph, then displacement is equal to the velocity times time. Okay. Now here, same thing, this area under the velocity time graph and horizontal axis represents the distance traveled. So for example, instead of just a normal velocity, we have a graph like this. So this is our time axis and this is the velocity axis. So whole this area will represent the amount of distance traveled by the object. Okay. Now the next point comes here, and that is our first question here that we are going to discuss about. And this question says, the diagram shows the speed time graph of the motion of an athlete running along a straight track. For the first 4 seconds, he accelerates uniformly. Uniformly means the acceleration is constant and he is moving from rest to the velocity of 9 meter per second square. So initial velocity, starting velocity is 0 meter per second because it starts from rest, and then our time is 4 seconds. After 4 seconds, the final velocity when it reaches over here, it is 9 meters per second. So this is the velocity I know in the beginning, and they said the velocity is then maintained for a further 8 seconds. So this is 4 seconds. For 4 plus 8, that is 12 seconds. For 12 seconds, the velocity stays same, which is 9 meter per second. Find the rate at which the athlete accelerates. First of all, athlete accelerates in this region, not in this second region from 4 to 12. What is the reason? Because here it is a horizontal line, and for a horizontal line, gradient is 0. And what is the meaning of gradient? Acceleration. So this part acceleration is 0. They are saying you have to tell the rate at which athlete accelerates. So athlete is accelerating only in this area. So when athlete is accelerating in this area here, so what we need to do? We need to find this acceleration. Acceleration is change in the velocity. So it is final velocity is 9 minus the initial velocity, which is 0, over the total amount of time, which is 4 seconds. So we will get the velocity acceleration here as 9 by 4, which is equal to 2.25 meters per second square, or you can write meters seconds and inverse 2. Then they are asking for the second part of the question, the displacement from the starting point of the athlete after 12 seconds. So when 12 seconds are completed, what is the displacement? Now displacement means the area under the velocity time graph. So here what I can do, this can be done in two ways. Either you split this whole area into two parts. One is the area of this triangle plus the area of this rectangle. Or you can see this is like a trapezium. So you can find the area of this trapezium directly. How to find the area of trapezium? It is half of sum of parallel sides. This one and this one. These are the two parallel sides. How long is this side? It is from 4 to 12. So it is 8 meters long. Sorry, 8 seconds is given. Plus the lower side, the full thing, which is from 0 to 12. So 12 times by the height, and height is how much? 9. So this is 20 divided by 2 multiply by 9, and that will be coming out as 90 meters. Because this is the displacement, so we will have to mention the unit as meters. Then we have our next question here. In the next question, diagram is again given. So when the diagram is given, it is a little bit easy, but we will be focusing more on the questions where the diagrams are not given. So here we have the diagram shows the velocity time graph of the motion of a cyclist riding along a straight road. She accelerates uniformly. So again, it is a constant acceleration from rest to 8 meter per second in 20 seconds. So now the time is 20 seconds. First 20 seconds, initial velocity, the starting velocity was 0 because it starts from rest. And then she reaches the velocity up to 8 meter per second. So the first point is, what is the acceleration in the first 20 seconds? So acceleration is the change in velocity. So 8 final velocity minus the initial velocity over the time, which is 20. So this is 8 over 20, and that is gonna be 0.4 meter per second square. How? You can times it by 5, you can times this by 5. So this is 40 over 100, and which gives 0.4 meter per second. Then the second part of the question is the deceleration. Now what is deceleration? See, when we use the word acceleration, this is basically shows that velocity is increasing. Okay. When the word deceleration is used, that means velocity is decreasing, or we can say acceleration is negative. If I say acceleration is a negative value or it is a deceleration, they have the same meaning. So now they said in the second part, the deceleration of the cyclist in the last 15 seconds. If you see the last 15 seconds, the velocity, this is from 60 to 75. So time is increasing, but velocity was 8 meter per second. And then it starts reducing and it became 0 after 15 seconds. So again we have to do the same thing here, and that is acceleration we will be finding out, or you can say deceleration. Final velocity is 0, initial velocity is 8 and divided by 15. So 8 divided by 15 minus 8 divided by 15, and that is equal to uh, 0.533, like that. So this is minus value. If you are using minus value, then don't call it deceleration but call it acceleration, because negative sign means is it's a deceleration. Or if you are writing deceleration, then you just write deceleration, and then you can write the positive value 0.533 meters per second square. Then we have the next part of this question, and that says the displacement from the starting point of the cyclist after 75 seconds. So up to 75 seconds, until this time is over, what is the displacement? So again, displacement means in velocity time graph, displacement is this area. So this is like a trapezium. Again, you can either find the area of trapezium, or you can split it into one triangle, then one rectangle, and again one triangle. So either way, you will be getting the same answer. So I'm going to apply the rule of displacement as the area of trapezium. So half of sum of parallel sides. So it is going from 20 to 60. And when it is going from 20 to 60, so basically what I can do here is we have to find out the displacement from the starting point after 75 seconds. So this is 40, 20 to 60, which is 40. And then in the denominator it is 40 this, then 40 plus 20, which is 60, 60 plus 15, 75. So the lower side is longer, this whole thing, it is from 0 to 75, which is 75. Then height, which is equal to 8, so we times it by this. So 2 and 8 will be cancelled out, so we have 4 times 115, and that is equivalent to 460 meters. This way we can complete our this question. Now we have more questions, and that I will be covering in our next lesson. So please keep watching these videos. Thank you.